Good morning everyone and welcome to the next video from Simplilearn. In this video we are going to discuss SQL injection and the types of SQL injection. This is what is going to be covered in this video. The first point will be we will be discussing what exactly is SQL injection. Then we will discuss the types of SQL injection. How does SQL work on a website? So SQL is a structured query language. We'll be discussing that a little bit. And how to prevent SQL injection. We'll be looking at basic pointers on what to utilize so that SQL injection is not possible. And then we'll be looking at a couple of demos during this video on SQL injection. So let's begin with what is SQL injection. As the name suggests, SQL injection vulnerability allows an attacker to inject malicious input into a SQL statement. So SQL stands for Structured Query Language, which is a language used by an application to interact with a database. Now, normally this attack is targeted towards a database to extract the data that is stored within. However, the vulnerability does not lie in the database itself. The vulnerability will always lie in the application. It is the developer's prerogative of how to develop the application, how to configure it to prevent SQL injection queries from happening. A database is created to answer questions, and if a question is asked, it is supposed to answer it. Database needs to be configured for some amount of security, but the vulnerability, the flaw here for SQL injection will always lie in the application itself. It is how the application interacts with the database that needs to be modified, that needs to be maintained by the developer rather than just configuring the database itself. So the attacker at this point in time, when they send a query to the application, will form a malformed query by injecting a particular command or an operator that is recognized by the SQL language. And if that operator is passed through the application to the database, then the database basically gets cracked or does a data dump because of that unwanted character coming in. So this character needs to be filtered at the application level itself. Now let's look at a quick demo. So what we have done here is I have this virtual machine called OWASP Broken Web Applications Virtual Machine version 1.2. I'm going to power this on. Till this powers on, I'm going to show you where we can download this utility from. So you can just look for OWASP Broken Web Application Project download. You'll find it on sourceforge.net. Click on the link. You can download the Broken Web Application Project from here. This is a 1.9 GB download, and you can have a zip machine directly for VMware or Oracle VirtualBox. Now, this is an application that has been developed by OWASP, which stands for Open Web Application Security Project, which is a not-for-profit organization and periodically releases the most top 10 risks that an application will face for that particular year. So they have given a web application with inbuilt vulnerabilities for professionals like us to practice upon, to develop our skills upon, because doing this in the real world is illegal. I cannot go onto a website to demonstrate how a SQL injection attack works. Neither should you try your hands on it till you become very well rehearsed with it. So to upgrade your skills, to upskill yourself, please download this machine, host it in a VMware workstation or an Oracle VirtualBox, and you can then try your skills on it. Right. So just going back to the browser here, if I open up a new tab, you'll see that this machine has booted up and has an IP address called 71.132. So if I just go onto that IP address and I type in 192.168.71.132, and you'll see the OWASP Broken Web Application Project, and there are a lot of training applications, realistic intentionally vulnerable applications, old versions of real applications, and so on and so forth. So there is a lot of applications inbuilt over here that you can try your skills upon. We are going to try to use the OWASP utility over here. This gives you the OWASP top 10 risks for 2010, 2013. 2017 is the latest one so far, but the difference between 2013 and 2017 is that some of these have changed, but not all of them. The order has changed a little bit, but you can see that SQL injection is on the top A1 amongst the injection attacks, right? And you can see there are multiple types that have been given here: the SQL injection for extracting data, or SQL injection for bypass authentication, or insert your injection attacks, blind SQL injection. And then there is a tool called SQL Map, which is available freely on your Linux machines, Kali Linux or Parrot Linux, whichever you want to use for your practice targets, and so on and so forth. So if I just take you here for bypass authentication, and this is a regular login page that an application may have, right? You look at a username, you look at password, you type that in, and you log in. So let's say I don't know a password here. I'm just going to type in the username test. Password is PASSWORD. I try to log in, and it shows me that the account does not exist. So the authentication mechanism does work. I did try type in a username and password. It wasn't recognized, so the account does not exist. Now let's try to type in a SQL query. Here I'm going to just give it a single quote, which is an operator that is recognized by the SQL language, which when the database tries to execute will cause the database to dump some data or to bypass authentication in this case. And I'm going to give it a condition, single quote, or 1 equals 1 space hyphen space, and I'm going to click on login. Now right now I'm not logged in at all, and we tried our username and password and we weren't able to log in. So now if I log in, you will see that it gave me a status update saying the user has been authenticated, and I'm logged in as admin, got root. So that is what these SQL queries can achieve. I'm going to log out right now, and we're going to look at the basics of SQL injection. So looking at that small demo, now let's look at what types of SQL injections are available. So the first is in-band SQL injection. There are two subtypes within in-band: error-based injection attack and a union-based injection attack. The second type is blind SQL injection attack, where there's a Boolean-based and a time-based attack. And the third one is out-of-bound SQL injection attack. Now, what is in-band SQL injection attack? In-band is where we are either attempting the error-based or the union-based. What is error-based? We send a query to the database, we craft a query to the database, and it generates an error message, and it dumps the error message right in front of us on the screen. That makes us realize that there is a flaw, and there is some information that is dumped on the screen, which we can then further utilize to craft our further queries as we go ahead. Whereas union-based is it is where we combine multiple statements at the same time. So if you look at the URL, earlier in the URL, you would see a large structure in that URL. We can try to add two or more statements within the URL itself to combine them and then confuse the database into executing both the statements together and giving a data dump at the same time, right? So what would an error-based SQL injection look like? If I go back to the same database, which is here, right? And if you remember the username, we gave it a single quote or 1 equals 1 space hyphen space. We gave it the condition, right? So basically what it did was a single quote is an operator that goes to the database, selects the default table in the user tables in this database column, and then compares it to the condition that is given. So the condition that we gave was 1 equals 1, which is always true. So what it did was it selected the default user table that was available in the database, and instead of comparing it to a password, it compared it to the condition. So if I give it 1 equals 2, where the condition is false, and if I log in, you will see that the account doesn't exist, comes back again, because the condition was false, and instead of comparing the user account to the password, it basically compared the user account to the condition. So if I give it a single quote or 1 equals 1 hyphen space and log in, you can see that this is a correct condition, and thus we are able to log in. Now, before we even go to that extent, if I just forget the condition over here and I just give it a single quote, the operator, and I send this operator to the database and I click on login, you will see that it generates an error, which is right on top. And it tells us the line, the file where the error happened, and you can see it happened in the MySQL handler.php file. Right, and then it gives us the message, you have an error in your SQL syntax, check the manual that corresponds to your MySQL server version for the right syntax to use. Now, why would a hacker want to do this in the first place? Because there are different types of databases. So there is a MySQL, MS SQL or Microsoft SQL, Oracle SQL, IBM DB2. All of these are variations of the SQL database. They use the SQL language. However, every database has its own command, right? They have their own syntax, they have their own specific commands that are utilized for the database. So in this scenario, the hacker wants to identify what database is being currently utilized so they can craft those particular queries. So now with this injection, with just me sending the quote and the error getting generated, I now come to know that we are using a MySQL server and the version of that server is 5.1.73. and the rest of the information about where the handlers are located and so on and so forth. Right, this gives the information to the hacker of how they want to proceed next, what kind of queries they want to create, what kind of syntax they want to utilize. So error-based attack is where you generate these kind of errors and you get this information. The union-based is where you craft your queries within the URL, or you can try to combine multiple statements within the input fields and try to generate a response from that. Then we come to Boolean based SQL injection. Sends a SQL query to the database which forces the application to return a different result depending on whether the query returns a true or a false result. So basically, if the input is false, both the inputs are false, the output would be false. There's one input that is false, the other input that is true, input B, the output would be true, and so on and so forth. Right, so depending on the result from the inputs, the attacker will come to know which input is true. With this, he can then access the database of the website. So you're trying to figure out by sending out multiple inputs and then analyzing the output to see what exactly, which command exactly worked, what was the resultant output of that command. Thus, from this kind of an information, the hacker can infer their next step forward. Then you have time-based SQL injections. Now, there are times when a database administrator or an application administrator has done some security configuration and thus have disabled verbose error messages. Now, what is a verbose error message? The error message that we saw right here is a verbose error message. That means that the message gives out details. The message gives out details about what the database is, the version and whatnot. So if they have sanitized these errors, and you no longer can generate these errors and thus you cannot figure out what database is, then what do you do, right? For example, if I just take you to Simplilearn and take you to a URL that is supposedly not accessible, you can see that it gives a generic error. Oops, like it looks like you have crash landed on Mars. It doesn't give you a verbose error that we saw here. So this gives us a detailed error of what went wrong, where it gives us the database, the version of the database, and where the query went wrong, and etc, etc, etc. Whereas on this side, where there's a lot of security that goes in here, so you can see that it doesn't generate a error. It just get a generic page in front of you. So in that case, what does a hacker do? So the hacker then injects a time-based query in the URL, which allows us to verify whether the command is being executed or not. So we put in a time wait, let's say 10 seconds of time wait. So if the moment we inject the query, if the query times for 10 seconds and then gets executed, that means that the SQL injection is possible. However, if we inject the query and it just gets executed without the delay, that means that the time injection attack would not be possible on that particular site. Out of bound is not a very common attack. It depends on the features being enabled on the database management system that is being used by the web application. So this can be a somewhat of a misconfiguration error by the database administrator, where you have enabled functions and not sanitized them. So you have not done in access controls properly. You have not given account control. So queries should never be executed at an administrative level. They should always be executed at a user level with minimum privileges that are required for that query to be executed. Now, if you're allowing these kind of functions to be enabled at the DBMS, and there is an administrative account that can have access to them, at that point in time an out of bound injection attack is possible. So let's look at how a website works, right? How SQL works on a website. Now, the website is constructed of HTML, hypertext markup language, which would include JavaScripting for functionality, cascading style sheets for the mapping of the website, right? And then React, JS and whatnot for further functionality. Now, when we send a query to the website, it is normally using the HTTP protocol or HTTPS protocol. When the query reaches the application would then go ahead and generate the SQL query. At the client side, you'll have all these scripting languages coming in on the front end that we can utilize to craft queries and then send them across. At the server side, you'll have databases like Oracle, MySQL, MS SQL, and so on and so forth that will then execute those queries, right? So just to give you an example, if I use a tool called Postman, what we generally do when we craft a query is we send out a GET request to the website, and then we receive a response from the site with the HTML code and everything. So this is a tool that is utilized by software testers to test the responses that you're going to get from various websites. So on the left hand side, you can see I've used it on quite a bit. Here we have an example for gmail.com. So let's continue with that. So this is a GET request being sent to Gmail. The moment I send it, it's going to create an HTTP request and send it across. The response that I get is this. This is the HTML code for gmail.com, right? These are the cookies. These are the headers that include information. So you can see this is a text HTML character set utilized is UTF-8, and the configuration that has been done with the application, right? So this is where everything comes in. This is the cookie that has been sent with that particular request that I had sent out. Now, if we analyze this query, right? So when we went on to this application and I typed in that single quote and we generated this error, right? You can see that the application converted this into a SQL query. So the query was select username from accounts where the username in quotes, single quotes, and we use the quote, right? The single quote right there. So that's where we use that operator, and that's where the exception error occurred. So these are the kind of queries that are structured by the application and then taken on to the database for execution. When we type in, it is a HTTP GET request with the username and password within that query that is sent to the application. The application converts it into a SQL query, sends it to the database, and the database responds with the appropriate response. So how do we prevent SQL injection in the first place? Use prepared statements and parameterized queries. These statements make sure that the parameters passed into SQL statements are treated in a safe manner. So for example, we saw that the single quote was an operator. This shouldn't be allowed to be utilized in the first place, right? So here, what we are doing here is a secure way of running a SQL query in the JDBC using a parameterized statement. Define which user we want to find. So there's a string, the email comes in. Connection to the database. We are going to figure out how the connection is going to be passed, how it is going to be created. Construct the SQL statement we want to run specifying the parameter, right? So we define how is it going to be created, what is going to be created, what can be passed to the database and what should not be passed to the database. So that is one way of utilizing prepared statements and parameterized queries. Then we have object relational mapping. Most development teams prefer to use object relational mapping frameworks to make the translation of SQL results set into code objects more seamless. So this is an example of object relational mapping, where we map certain objects and allow that to be executed. And then escaping inputs. It is a simple way to protect against most SQL injection attacks. Many languages have standard functions to achieve this, right? So you need to be very careful while using escape characters in your code base when a SQL statement is constructed. Not all injection attacks rely on abuse of code characters. So you need to know what characters are being utilized in the configuration that you have created, in the structure that you have created, in the code that you have created. Which characters are being recognized as operators. You need to sanitize those operators, and you need to basically ensure that these operators cannot be accepted as user input. If they are, they're weeded out by the application and they never reach the database. Other methods of preventing SQL injection are password hashing, so that passwords cannot be bypassed, the passwords cannot be recovered, passwords cannot be cracked. Third-party authentication. You use OAuth or some other service for a single sign-on mechanism. Thus, you rely on a third party to maintain the security of authentication and what kind of parameters are passed. For example, using LinkedIn logins or Facebook logins, right? For the layman, you normally go onto Facebook and you allow, if you're using a game, right? If you start playing a game, you're allowed to log into the game using your Facebook credentials or your Google credentials. Now that is not just for ease of use, but the game user, the developer, has outsourced the authentication mechanisms to third parties such as Facebook or Google, because they understand that that authentication mechanism is as safe as can be. Facebook and Google are wealthy organizations, hire a lot of security experts, and the development for their authentication mechanisms is top notch. A small organization cannot spend that kind of money on security itself, right? So you use a third party authentication mechanism to ensure that these kind of attacks may not happen. Then web application firewalls. Having a web application firewall and configuring it properly for SQL injection attacks is one of the sure shot method of mitigating or minimizing the threat in the first place. So at this point in time, you have realized that the application has some vulnerabilities for SQL injection, and instead of recoding or restructuring the application, you want to take the easier way out or the cheaper way out. So what you do is you install a web application firewall and you configure the web application firewall to identify malicious queries and stop them at the firewall level itself, so they never reach the application, and thus the vulnerabilities on the application don't get executed. Buy better software and keep on updating the software. So it's not necessary that once you have a software, you install it, it's going to be safe for life. New vulnerabilities are discovered every day, every hour, and it may so happen what is secure today may be completely insecure tomorrow or the day after, right? So you need to keep on upgrading the software. If there are no upgrades available and the vulnerability still exists, you might want to migrate to a better software and thus ensure that you don't get hacked, right? Always update and use patches. Organizations keep on sending out updates and patches as and when they are released. You need to install them to enhance your security postures. And then continuously monitor SQL statements and databases. Use protocol monitors, use different softwares, use the firewalls to keep on monitoring what kind of queries you're getting. And based on those queries, you want to ensure the inputs and the queries that are creating are not detrimental to the health of the software that you have. So the key takeaways that we have seen here in a nutshell are: what is a SQL injection attack? We have seen the types of SQL injection attack, how it works, and how to prevent SQL injection attack. Now we have done a couple of demos. If you want to know more, please comment in the comment section of this video. Get in touch with us and we can definitely help you with more deeper insights into what a SQL injection attack is. That's it for this video. I'll see you in the next. Thank you and take care.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.